Welcome. So today we are going to discuss about small agents. This is agentic framework from Fix. So you already familiar with large language models or LLMs like ChatGPT. So we are going to discuss about how agents are different from large language models or LLMs and how we can implement for our business use case. So let's get started. So we know like LLMs or large language models are likely they are smart text processors. We can say like they can read and write based upon statistical patterns they have learned from tons of data, but they themselves cannot able to do anything. Like they are all reactive in the sense like you ask something, they will respond. So they don't have memory, they don't learn actively, and they are limited to just text processing. So this is about LLM. So now if you can see the diagram here, like the image. So this is a conceptual diagram of an agent where it has a brain in the sense like it is nothing but an LLM which was trained on large amount of data. So it has its own knowledge, plus it can able to retrieve knowledge from document source, or like we can say it's like a RAG pattern, Retrieval-Augmented Generation, and then it possesses storage. So based upon that it does the decision making. So it can do actions like let us see, like here it is given like what's embed large language models. So we already discussed, give us an input, it will process the text and give us give some outputs. That's how large language model works in simple terms. So they are a great comprehension of human language, but they don't perform an action outside of their knowledge base. That's one thing. Like whatever they possess or trained upon, only those things can able to retrieve and give it you as an answer based upon your question. But on the other hand, agent is an autonomous program that performs tasks. So this is the important. So that performs tasks, makes decisions, and communicates with other entities. So other entities, like usually it may be a database, it may be a vector database, or any other API call it can perform and do the action. So usually agents are provided a set of tools. So tools like yeah, we will discuss what are tools, and they can decide to use what to use while completing a task. So this concept extends reinforcement learning. Like this is a little bit of reinforcement learning where an agent picks from different set of action to maximize the reward in interactive environment. So now we know like LLM just gives words, like you input a query and give an output in the form of words, nothing more than that. So you can, if for example, if you ask write a Python program, it can write and give it to you in the form of a string of words. Now on the other hand, agents which takes LLM outputs plus task completion based upon that outputs. That is important thing here. So it can take an action based upon that output, LLM output. So generally the brain will be LLM, a large language model with the memory added, and you can see here it can have a memory knowledge, and then the environment. So the environment here you can see like from where it can get. For example, if you're asking about weather, it uses the tools, like set of tools, like for example in API call to a weather database, and then it gets the appropriate output and parse it, and then take an action based upon that output. For example, if a user asks an agent that should I take an umbrella today, so it parses that one, and then it thinks like, okay, so umbrella, okay, so the user asking about umbrella, so do then it based upon its own set of tools, it processes it. Okay, so now it decides like it has to use weather API call, so it calls a weather API call, and then it initiates a call to weather API and then gets the local weather, and then based upon that it gives an action. So okay, either you can take an umbrella or not. So there are different perceptions we can take, like based upon the inputs, the multimodal, like it may be text, it may be a click of a button or maps, whatever may be. So this is most advanced, but this is the basic thing, like you, the agent which has a brain. The brain consists of a storage, memory, and a knowledge, and then based upon that you give a set of tools. So when you ask a question, so it will use the tools and gives you the answer, or does a perform a task. Okay, so this is a basic overview of an agent. So today we are going to discuss about there are different agentic framework like QA, small agents, the different agentic framework. But now we are going to discuss in this studio. We are going to discuss about small agents. So you can see here, this is a small agents given by Hugging Face, the Hugging Face agentic framework. So this is very simple with less complexity. That's the beauty of this particular agentic framework. We will discuss how we can implement that. So if you want, you can go through this particular page where they give in-depth detail about what is agents and how we can use this for your personal use case or specific use case. So all these things we will discuss. Like it was given detail in this particular page. So feel free to go through here and have a look. So now we are going to implement the same, but first we are going to start with implementing a simple agent where it calls or it it goes to a Google search and then gets the information from whatever the user asked. Okay, so let us start installing the required packages for this. So well, let it install. So once, like in apart from going for a basic small AI agent which can browse a web and gives the answer, we are also going to discuss about how we can use an agent to retrieve the information from vector database. So we can call it as a agentic RAG. We know like RAG is Retrieval-Augmented Generation. So we use an agent to do the work. Based upon the query, it goes and fetches in information and then summarizes and gives it back. So that also we'll see first, but let us first basic simple agent which browses the website and then gives the result. So let us wait this until the package is installs. Okay. So I'm going to I'm just using a CPU, not GPU here. So I will pause the video and I will come back. Yeah, now you can see like all the tools has been like record packages has been installed. So now we are going to create an agent which uses website page tool. Now I'm just importing all the required packages. Now for example, if you see here from small agent importing code agent, API model and tool calling agent and light LLM model. So light LLM model means later we are going to use OpenAI. So for that I'm importing these things. So in small agents they are given a default tools like you don't need to create a separate tool for an agent. Like especially if you want to go and visit a web page tool, like go and search a web page, then they can use it. And there is also a DuckDuckGo search tool, which is by default they are giving. We can directly use those things. So this part in later in the video I'm going to use a RAG. For that I'm using this one. And obviously you need to it is better to have a Hugging Face token or stored in secrets, and then you can get it from there. So if you want to know how to get it, go to Hugging Face and create a login and then create an account and then go to settings and you can get the Hugging Face token, as well as same for OpenAI API key. This is specifically we use when we are using OpenAI model. Okay. So I'm testing it with Alpha Vantage for getting financial stock codes. Okay, but now we are not going to use it. So here let us start by using OpenAI API like GPT-4o, which is the latest one. I'm declaring model here, which model to use, the light LLM framework. You can see here what, like you can use Anthropic, like this is one abstraction, like where on top of this small model we can pass any, not only not any LLM, not only Hugging Face specific LLMs. Okay, so now I'm creating an agent. So this agent can use, this is a code agent, and then it is given a set of tools. So tools, we are giving a visit a page tool, and the model we are specifying which model to use. So we are going to use this by specific model, and this is how we are going to run it. So now if you see this this, okay, so we have an agent. So the background brain or the backend brain for this agent is GPT-4o, which we mentioned in the model, and then we are giving a tool. So we are giving a web page tool. So sorry, visit web page tool, I think, yeah. And tool calling the, yeah, visit web page tool, which can able to use this tool like to search any user requested query and then get the answer. This is a simple agent. So let us see how it works. So I'm going to ask a question: who is the CEO for Toyota? Let us see how it behaves. So just started it. Let us see. Okay, so started. The agent was running now. See here? Okay. Yeah, the CEO, president member of Toyota is Koji Sato. Okay, let us confirm that one. We'll just copy and paste the same query and confirm. First, let us confirm the answer, whether it is correct or not. Okay, so Koji Sato is the CEO of Toyota. Okay, so now this is the flow. Like if we can see these logs, like first this is a user query, and with the user query and what model we want to use, we specified it. So step one. Okay, so it directly goes to Toyota page and then get the executives, like whatever it is. So it is here if you see, it is a code agent. It creates a code and runs it and gets the output, and from that output it parses the whatever the output it gave, and then it sends to the LLM, like LLM parses it and gives the final answer. This is how it works. Okay, step one, it gets the user query and it knows what model to use, and then it creates a Python code, and then from that code output it gets the answer. So the LLM will parse those outputs and then finally gives the answer. So now we will use the same question, and then we will try to ask with the different model. Okay, so we will so define a little. Okay, so sorry, we will comment these things, and then we'll ask the same question with a different model. Yeah, will be yes. Okay, now we are going to use model Quen model from Hugging Face API. Let's see how it behaves for the same question. Okay, so there are some few errors. Okay, too many requested, generating too many requests for URL. Okay, so there are too many requests for this URL. That means it's not using Hugging Face token properly. Okay, so let us try one more time. Yeah, I think the too many requests, same. We'll pause the HF token here. So okay. Let us try with the HF token. Yeah, so with the token I can able to work. Like I will try it again. Yeah, so it's doing. Yeah, okay. See the different steps, like it trying different methods. So it's thinking even technical. Okay, is it correct? No, I think it is wrong. Let me check again. Koji Sato. Oh no. So it is not getting the correct answer. Previously we used GPT. It is giving correct answer, but for some reason Quen it's not giving the correct answer. We will try it again. Okay, it's not getting the correct answer for some reason. Okay, we will try with a different model, Hugging Face model. Just give me a second. I will just. I tried different methods, but this GPT-4o was giving a correct answer for some reason. So these are the steps. So it goes and searches for Wikipedia, and then parses the content what it searched, and then gives the final answer. So now let us try asking a different question. Just proposing. Okay, so let us try this one. Okay, so we're using OpenGPT-4o. Okay, so this is good. Acting on the model to API, taking so long and giving a lot of errors, even though the key was correct. Okay, so now this is the first part where the agent was defined and given a task with the tools. So with this, the agent takes the user query task, and then by using a given tool, it does the task and then give the solution as a final answer. So now we will go to the second part where we are going to give agent with the retrieving capacity. So like we are creating a retriever tool which can able to retrieve does the semantic search and retrieve the documents. This is nothing but Retrieval-Augmented Generation, and then we are going to ask the question. Okay, so here I will create a folder name called PDFs. So that's how I structured the code. So it has to search the PDFs document, and then from there whatever document we input, it has to do the loading part, and then do the text splitter, and then split the documents, and then finally do the embedding. So I'm using the simple basic sentence transformer embedding. And the tokenizer, this particular tokenizer GT small. Since this is a demo purpose, I'm going for a basic setup here, and then this is a tool which I created. Like I can just giving a small description using a semantic read to the parts of document that could be most relevant to answer your query, and then query is the string, we are pausing it, and the description of the query to perform. So semantically close to the target documents with the affirmative from rather than a question. Okay, so Okay, so these are the steps to perform, and then retrieve documents, and both those retrieve documents and the prompt will be passed to the, and then we will see how we get documented answer. So let us first create a document, sorry, folder here, and then we need to upload the documents. Okay. Yeah, so I created a PDF folder and then uploaded two documents. One is NVIDIA and then the other one is Tesla. So these are the two documents I uploaded. Now let us start the process. Okay, so this particular code block will create documents, do the splits, and then it will create embeddings and then store those embeddings in a ChromaDB. So for embedding, I use a sentence transformer all mini LLM V2 L6 V2, and for tokenizer I'm using GTE small. So this is the tokenizer, and then this is the embedding model I'm using. Okay, so let us start. It will take some time. Oh, we got some errors. No model name datasets. I think we don't need these datasets anymore. Okay, previously I was testing something. Okay, so it's working now. Okay, so it will take some time. I will pause and come back. Yeah, so this took almost almost 7 minutes, and we created a ChromaDB with embeddings. You can see here. So now I try to ask a question. I try to ask a question like, so this is this error like where I was previously using another retrieval tool like search agent. So that's why it's complaining. But so now I asked a question: who is Robert K. Burgess? So now this is from NVIDIA document, and I'm using the model OpenAI GPT-4o. So it did a correct search, and then see. So to determine who is Robert K. Burgess, I will conduct a semantic search using retrieval tool. So that's the tool we provided to this particular agent. You can see here. So this retrieval tool was constructed before, as we discussed earlier, where the documents will be split, and then it will be converted to embeddings, and then the embeddings are stored in a ChromaDB. So it correctly uses that particular tool, since that's the only tool we gave here, but uses the tool and retrieves the relevant documents, and then finally gave the answer. Okay, so now we ask the same question with a different model using Quan. So let us see how it gives the answer. Okay, there are some issues in accessing Hugging Face. Okay, so this is how it works. So now we will ask one more question on Tesla. Let us ask some typical question. Okay, so what is foreign currency translation adjustment? Let us see whether it can able to answer the question. Okay, so we will okay, for 2024, let us ask like a very generic question, see whether I can able to answer this one or not. Timing, I will comment this one. Okay, so no, we need to again run the model thing. So model, where is the model? This one we need to, because we run that one, right? Okay. Okay, this one is not. Okay, yeah. Okay, see, it's getting a. I did mention which document to browse or which company. Foreign transnational plus loss and in 2020, for example, it includes 756 million for impact and person exchange. I don't know whether it is okay. Something else, but we don't know what exactly it gave. Let us ask the same thing. Okay, maybe correct, but we don't know like where from where exactly it took the answer. Okay, so let us ask which is more relevant to Tesla. Okay, so is there anybody name there so that we can ask here? Not too much. Okay, so we will ask something which is more relevant to Tesla here. Financial statements. Okay, so accounts payable for June 2024. We'll ask this. Okay, so we will see whether it is retrieving this correct answer. I given should retrieve from Tesla, so mentioned it Tesla. We will see, maybe it may get the correct answer. could not be found rated or it may be data actually complete financial disclosures. Okay, so it couldn't able to get for some reason. Maybe we can able to fine tune the prompt and then get the RAG working properly. But this is the premise here. Like we will ask one more question from this particular. Okay, so we will ask. Okay, so we will ask the age. We did some documents, but it couldn't be able to fetch the correct answer from this. Let us see how it works for this particular question. We'll give the name and then what. Okay, based on retrieved documents. Okay, so we need to fine tune the prompt and then the chunking strategy, all the stuff that then it may work properly. Yesterday we was testing, it was good, but for some reason it is not giving a correct answers today. Let's try one more last question. Okay, so direct compensation for physical year. Let us ask this one. Maybe my question is too general. Okay, so let's try this one. Okay, direct compensation. Okay, give some answer. Summing up total 359,268. 359,268. Maybe. Okay, some answer. Okay, so guys, this is what I want to show you today. So we discussed about what is agents and how we can implement an agent using a small agenting framework, agents framework from Hugging Face. And also we saw some quick demos like how we can use an agent by giving some tools, how it can perform step-by-step thinking and answering the queries. And finally, we try to implement RAG, like agentic RAG, using the same framework. We found some results good, but some not as expected. So this can be further fine-tuned by properly giving the prompt and as well as the chunking and embedding strategies. If we use properly, we can able to achieve good results. So we already discussed about how the agent uses RAG tool. So now the previous question we gave only the RAG tool, sorry, retrieval tool. So now we are going to give choices of tools like retrieval tool, visit web page tool, and DuckDuckGo search tool. I tried this question. It correctly chooses a specific tool and then finally gave the answer. Yeah, this is the answer. So on February, snowy conditions affected which related to search. Okay, it can either use a page tool or a DuckDuck search tool. Okay, so what is the share price of ask we don't want to ask Tesla or Nvidia. We will ask Amazon. Okay, so it directly goes to web search. Okay, closing these things, go to okay. Zep's Amazon is 229.15, 220. Okay, so let us confirm. Yeah, 229.15. So 229.15. Yeah, that's correct answer. Yeah, guys, this is what I want to show you today. Hope if you find useful, please subscribe and then share. Thank you.